Everyone, thanks for you to join. Welcome to our first end-user webinar series in 2013. Those who attended our previous sessions, welcome back. Today's talk is actually quite interesting, and it is going to be about one of our latest developments, Chinese name to structure, which was developed to accommodate the growing Chinese scientific literature and help in Chinese text mining applications. Today's presenter is David Deng. Just a few words of him. David graduated from Peking University in China in 1999 with a chemistry degree. Then he received his PhD in computational chemistry in the US. He was a postdoc at Yale University and University of Washington. And in 2009, he joined the cheminformatics group at Roche in Nutley, New Jersey, and there he was working on a patent analysis side. And finally, in 2011, he joined ChemAxon as an application scientist. Currently, is based on our Boston office. We can start just in a moment. A few more things beforehand. If you have questions, please do type them into the question window so that we can answer at the end. And already see that there are questions, although we haven't even started the webinar yet. So some of you are pretty eager. And there is another one. So we're going to have a few more webinars after that. You can see it on the screen. There's going to be a webinar about our calculator plugins, prediction of physical-chemical properties during early drug discovery. There's going to be one about one of our latest developments, again, a compound registration system, and one about query features in ChemAxon tools. And also, we record this webinar so that it will be available for you to download in the future. So with this, I ask David to continue.
Thank you, Christian. Hello, everyone. My name is David Deng. I am an application scientist. I'm based in our office in Boston. It is my pleasure to start this year's webinar. Today, I'm going to talk about the latest features, advances in our naming tool, particularly the Chinese name to structure, and also its application in Chinese text mining. For those who are not very familiar with our naming technology, I'm going to spend a few minutes first to give a brief introduction. Our naming tool can convert structure to name. It could be a UTAC name or traditional name, and also from name to structure. We recognize different types of names. It could be a UTAC name or common name or trade name, even CAS registry numbers. And then we applied name to structure into other platforms, particularly in document to structure, which is a tool that extracts chemical information from documents. And we also apply this technology to other systems, for example, document repository systems like Documentum and SharePoint. Then we have document to database and ChemAxon for SharePoint to help you index chemical structures and extract chemical information from documents in these repository systems. And we also apply that to ChemicalEyes.org. Some of you may have used it. It's a free web service we set up to extract chemical information from web pages and documents. So here's an example of structure to name. This is the structure of aspirin, and our naming technology. Structure to name can convert the structure to the AUPAC name and also the traditional name, which is aspirin. And also, we can do name to structure conversion. We can convert IUPAC name and traditional name to the structure. Like I said, we also recognize other types of names. For example, a non-standard systematic name or a trade name. Aspirin, which is a oral form of aspirin. These names are all recognized by our naming tool, and you can generate the structure from them. And we also can convert CAS registry number. This is the CAS registry number of aspirin. And we use a third-party web service set up by NIH, and we can convert the CAS number to structures as well. Then we apply name-to-structure technology to other platforms, and then we have document-to-structure. If these informations are in the document-to-structure can index them and convert all these information to actual structures. And it goes beyond just name and CAS numbers. If there's smile strings or inchi, these information will be converted as well. And also, if there is a image, structure image, we use author to convert them to structures. And document-to-structure is a very powerful tool because it works with different types of document. It could be a PDF or plain text or a Microsoft Office document. And this is a very powerful tool for pattern mining because it works with non-text PDF, because a lot of chemical patents are not actual text document. It's actually an image PDF. And we use OCR to first convert the image PDF to full text and find all the chemical information, and not only return the structures, but also the location of these structures in the document. So it's very useful for pattern mining. Of course, OCR technology has limitations, so they often make mistakes. We also have a correction algorithm that looks for the common mistakes that OCR makes and correct them for you. In this example, here, as you can see, methyl, after OCR is RNN, and YL is Y1, letter O is 0. All these mistakes will be corrected by our algorithm, and then document-to-structure can generate the correct structure for you. Like I said, we also apply this to document-to-structure to other platform. There are a lot of internal documents, especially in the big corporation. So many companies use document repository system like Documentum or SharePoint, and document-to-database can pull documents out of these repository systems, extract all the chemical information from them, and save to another database. Then you'll be able to not only look at the structures, the location in the document, and also other metadata like who is the author of this document and when was this document created. SharePoint is also widely used, but it lacks of a chemistry handling function. So you can, for SharePoint, use document-to-structure technology, and you can not only sketch structures on a SharePoint web page, you can also, if you have documents with chemical information in it, you can, for SharePoint, you can look for these chemical information and index them for you, and then you'll be able to do structure search across your SharePoint platform. And we also set up a free web service called ChemicalEyes.org that can extract chemical information from web pages and documents. This is the homepage of ChemicalEyes. You can simply paste a URL of a web page, or you can also upload a document, and ChemicalEyes will look, basically read this document or web page and look for all the chemical information in this page and convert them to structure for you. So this is a free web service. Anyone can use it. You don't have to sign up. One thing you do need to keep in mind is that because this is a public service, all the structures extracted from the web page or document will be published. So do not try this on any confidential document. So that was a brief overview of our naming technology and its expanded functions. And Chinese document, and China now has overtaken U.S. and become the #1 patent filer in the world. This is a plot I retract from The Economist last December. As you can see, China is now #1 patent filer. So there is a huge chemical space in the Chinese scientific literature and Chinese patents. So it will be useful to have a tool that be able to extract chemical information from Chinese documents. So we need a new Chinese name-to-structure tool to simply convert Chinese chemical names to structures. But one thing I want to point out that even before we decided to work on Chinese name-to-structure, you can use our regular naming tools to convert some Chinese name to structures. Because our naming tool comes with a customized dictionary, you can put customized conversion from structure to, from corporate ID to structure, for example. And if you have our ChemAxon tool installed on your computer, there is a customized names.smiles file on your computer, and you can. This is the customized dictionary, and you can simply add customized string and structures to this file. This is located. If it's on Windows, it's located on username ChemAxon. And the format is very simple. You simply put the smiles of the structure, separate by a tab, and you can put any text string after that. In this case, it's a corporate ID. It's a ChemAxon, the first compound of ChemAxon. But this really can be anything. It doesn't have to be English. It doesn't have to be alphanumeric. It really can be anything. So let's take a look of my customized dictionary. It is on my computer under C drive user David ChemAxon, and this is the file. So let's take a look. As you can see, I have 10 structures with corporate ID. These are actually the top 10 best-selling drugs. And you can also put ignore at where this mouse will be. That means you want to ignore this text string on the document because, for example, ATP can be adenosine triphosphate, but it can also be association of tennis professionals. So to avoid confusion, I simply want to ignore converting ATP to any structures. And at the bottom, I have the smile of aspirin and also Chinese name of aspirin, Japanese, and Korean. So with this customized dictionary, I'm able to not only convert customer ID to structures, but also customer names. So here is the text document. This document contains all the above corporate ID and also these non-English text names. Now we can simply use document to structure to extract chemical information from them. So let me start my Marvin view. To run document structure, you simply use our Marvin view, which is a lightweight molecular visualizer, and open this PDF file. As you can see, Marvin view quickly looks into that PDF to extract all these structures from corporate ID. And if you scroll down to the bottom, they also convert these customized names to structure as well, according to the customer dictionary. So this way, you can kind of, if you have a collection of Chinese name and structure, then you simply add them to the dictionary, and you'll be able to convert them to structures. And another thing I want to point out is that starting from version 5.12, which will be released probably in a week or two, you can also call this customized dictionary using a web service. So before 5.12, if you have a collection of corporate IDs, then every user in your company needs to have this file on their computer. It's very difficult if you want to add new compound or make changes. But after 5.12, you can simply call a web service and do this conversion. In this way, this library can be at a centralized location, so it's much easier to maintain this database. Of course, this is just a temporary solution. Even if you have millions of structures in your library, you cannot cover the entire chemical space. If you have a new chemical name in Chinese and that's not in your dictionary, then you won't be able to do the conversion. So what we are developing, Chinese name to structure, is not to use the dictionary, but use the algorithm to convert the Chinese name to structure. But actually, the real, or the Chinese name to structure tool we're developing is not directly go from the Chinese name to the structure, because that's actually quite difficult. But lucky for us, we already have a mature English name to structure conversion. So this is the IUPAC name of aspirin, and this is the Chinese IUPAC name of aspirin. As you can see, even if you don't read Chinese, you can tell these two names are very similar. Both names start with number 2, with, and then something in parentheses, and then something on the second one. That's because Chinese IUPAC names also follows most of the IUPAC rules. That's why they're very similar to English names. So what our Chinese name to structure tool does is simply translate the Chinese names into English, and then use our English name to structure tool to convert to structure. And because the Chinese name follows the IUPAC rule, as long as we can map all these Chinese words into the English equivalent, then we'll be able to generate the English name. Here is a table of some of these conversion we did. So for example, the prefix of meth is jia, and then ETH is excuse me, and benzene is ben. Indole is indole. So as long as we have a dictionary of these mapping rules, we can simply look at the Chinese name, find this mapping, and then simply replace them with the English text. Then we have the English name, and then we can simply convert them to structures. So that sounds easy. Well, that's because that's the good news. And here's the bad news. After all, Chinese and English are different, and they're actually quite different. For example, Chinese names, there's no space in between. This is the Chinese name of ethyl acetate, and for English name, there's a space in between indicating this part is the ethanol and this part is the acetate. But for Chinese, there's nothing in between. They're all equally separated. For Chinese people, we are trained since elementary school to how to basically put a mental space in between. But for people who don't speak Chinese or for computer program, then it's difficult to do that. Another challenge is especially for ester and salt, the sequence of the name are different. The same example, acetate, the structure has the acid part and then also the alcohol part. For Chinese names, you actually say the you actually say the acid part first, and then you say the alcohol part. But for the English name, it's reversed. You actually say the alcohol first, and then the acid second. This applies to all esters and salt. So we need to change our algorithm to be able to recognize these names. And also, for English names, it's also different because, for example, for butane, BUTA is the prefix of for carbon, and then ANE is for arcane. Well, if you put them together for English names, if there are two A's next to each other, you actually omit one of them. Then you have butane. But if you do not know that and simply put buta and ANE together, then you have an incorrect name. And another challenge is in Chinese, we use many characters, and they could have different meaning according to the context. For example, yan actually means salt, and suan means acid. But if you put these two characters together, yansuan, that means hydrochloric acid. So it depends on where you use it. It's actually, the meaning can be different. And another challenge is many times the Chinese name, it could be abbreviated. So for example, benzene in Chinese is but phenol is benji, but in many Chinese names, these two are interchangeable. So they use benzene in many cases for phenol, and also phenol for benzene. So in this case, when you translate into English, it could be wrong, or it's actually not the correct name. Then you cannot generate the structures. These are just some examples of the challenges we have encountered. So the overall solution of all these is to actually make our English name to structure more tolerant. So even if the translation is not perfect, maybe the sequence is wrong or something is wrong, our name is able to recognize our naming tool will be recognize these English names and convert them to structure. Here is the our test result. We don't have a test set, so we use the internet and look up 30,000 Chinese names and their cast numbers, and we use it our test base. This is actually, as said, with a lot of common names, and because we mostly focus on using the algorithm to convert IUPAC names to structure, so we're not working on the common names at this moment. So for those IUPAC name, which is about 60% of this test set, for those names we can convert to structures, the accuracy is close to 90%. And we're currently also looking for another test set, a real test set, which means it's better to be from a Chinese patent. So if you know or you have such test sets, you're welcome to be our evaluator. Now I want to give a little history of our development version. For English names, right now we're at version 5.11. 5.12 will be released probably in 2 weeks. So for the English naming tool, we first have the name to structure capability at version 5.1. And then in 5.2, we added the document to structure. But that only applies to full actual text document and it doesn't work on image PDF. It doesn't work on structure image. 5.6, we add structure image conversion using Oslo. And then in 5.8, we added the OCR capability. So document structure after 5.8 will be able to work on not only non-text PDF, also structure image in PDF. For Chinese name to structure conversion, it will be released in 5.12. But the good news is because we already have all the document to structure technology in place, so we simply add Chinese name to structure capability on top of them. So in 5.12, not only you can do Chinese name to structure conversion, it also applies to documents with Chinese text in them. The only thing that's not available is to do Chinese OCR. Because right now there's many directions we can go with this tool, so we rather have a first release and collect some feedback and decide where is the next, which are the top features which we should implement first. So now I want to do a little live demo. Let me go to Marvin Sketch. This is Marvin Sketch. That's our structure sketching tool. You'll be able to sketch a structure in it. You can also convert name to structure. For example, if I type Viagra, click import, it will generate the structure of Viagra. And in version 5.12, you'll be able to convert Chinese name to structure. So for example, I can type in and click import. It will generate the structure of aspirin for you. And let's try a longer name. So I have a longer Chinese name from a patent. Click import. And it will generate the structures from this Chinese name. Here is another example. I have a text document. This is a document I use for document to structure on Chinese name. It has 4 pages. The first page has a Chinese IUPAC name. The next page has a common name. This is aspirin. Remember, that's in my customized dictionary. The next page, we have some CAS registry number. This is CAS number for Viagra and Plavix. And the last page, we have a structure image of Tylenol. So now I can use document structure to open this PDF and extract all this information out. I can start Marvin View and use it to open the PDF file, or I prepared a batch file. I can simply run this. As you see, document structure can also run from command line. So this is simple command. This is the location of Marvin View, and this is that PDF file I just showed you. And you can also add more options in this command. So D2S means I want to do document to structure, and then plus CAS. That means I want to also convert the CAS number to structures, because for document to structure, the default option is not to convert CAS number. But in this command, I basically tell the program, please also extract the CAS number out. And here is the result. As you can see, this is the structure of the IUPAC Chinese name, and that's on page 1. And this is the common name. And the type here shows custom. That means this structure is from the customized dictionary. And that's on page 2. And on page 3, we have 2 CAS numbers. They're both converted to structures, diagram, and playlists. On the last page, it shows it has a structure image. That's why the type shows OSR. And now it's covered to the structure of Tylenol. So that's a brief demo of our Chinese name to structure tool, and also how to use it using Chinese document to structure. As you can see, this is a very powerful tool. And now that we figure out how to convert Chinese name to structures, we opened one door, but that actually leads to many other doors. Because similar to Chinese name to structure, if we can figure out how to map other foreign languages to English, for example, Japanese or Korean or Russian, then we have another tool for Japanese name to structure or Korean name to structure and so forth. And even if we finish all these languages, that's still only half of the work, because we then can also work on how to convert structures to Chinese names and other names, for example. So like I said, there are many directions we can go, and we're happy to collect feedback from our customers and see which features will be our top priority to work on next. That's all for my webinar. So the Chinese name to structure tool is developed mostly by Daniel and me. Many people know Daniel. He's the project manager of name to structure and document to structure, document to database. And this is my Chinese name. A lot of people probably don't recognize it. So the first thing I need to do is, similar to our Chinese name to structure, convert it to my English name. Then you probably remember my face. That's all for my presentation. Like I said, we hope that you can be our evaluators, and we're eager to hear what you like to say about this new tool. Thank you.